So next up is Giovanni Bassi, and he's going to be talking about analyzing memory dumps of .NET applications. Hello.
Hey Kendra, hello from Brazil.
Hello. How are you doing?
I'm fine, how are you?
Doing great. Excited to learn more.
Great, that's what we're here for.
All right. Yeah, you want to take it away?
Sure, let's go. Hi everyone, I'm Giovanni Bassi. I'm a Microsoft MVP and you can reach me at in Twitter at Giovanni Bassi. So if you have any questions after the session, I'm glad to help you because this is a quick 30-minute session. So let's dive in. So we're gonna talk about memory dumps and then we'll see a little bit about WindyBG and symbols and then we're gonna have some demos. So let's talk about memory dumps. So imagine you have a production problem, right? So your application is failing somehow and you are not sure why. So you might have a memory leak, you might have a high CPU demand, you might have crashes which you cannot reproduce. You cannot reproduce any of those. So what do? You cannot debug them. And when you run this application on your machine, it works, right? So you don't know what's going on and you can't debug. The environment is restricted or inaccessible, or maybe you do have access, but it's going to impact the performance and the application cannot be impacted that way. So in this case, you basically have a problem in production that you can solve through an easy, usual way, right? So what do? Memory dumps come to the rescue. You kind of take a picture of the memory, and you get to see everything that's going on within the application, and you can. This picture is actually the memory dump, and you can then bring this dump to your machine, and then you can analyze it. You can take a snapshot, this memory dump, when you demand it. You can just run an application that will take the memory dump for you, or you can also trigger it when the app crashes or hangs. So you can leave it running for a while, and then when the application finally hangs, then you get the dump. It will bring all the application context for you, so environment variables and system information. So this is very dangerous because this includes all the application state, including secrets, connection strings, and all the system information that the application was using. So you should be very careful with how you handle this information. You shouldn't give this memory dump to somebody that doesn't have to have access. Usually, what we will do is this memory dump will be analyzed in a lab environment with controlled access. Okay, so you should never ever share a memory dump freely. You shouldn't send it in an email. You shouldn't do that. Okay, always treating it as you are treating your connection strings very carefully. Dumps can be taken in various ways. So you can use the test manager in Windows. You can do it right now in your machine and you can take the memory dump. You can use Process Explorer or ProcDump from sysinternals. They will help you take dumps, and they actually you can configure it ProcDump to take a dump at a specific point in time. Visual Studio is also able to take memory dumps. AD Plus is an old application from Windows that you can use to take memory dumps, and you can also set it up so you can take a memory dump on an exact point in time. And the two new ones are .NETDump and .NETGC dump, and we'll talk about those two a little bit more. I just want to show you how easy it is also to do it on Azure. It's super simple. If you access the Kudu environment on Azure App Service, you can simply right-click on the .NET process or the XC process you have running there, and just require the memory dump. Yeah, I recommend you usually take a full dump, which will be the size of the memory, because it's actually a map of all the memories. So be careful with that because it might be really big. So if you're using, for example, 16 gigs of for the application, the memory dump will have 16 gigs. So this way, it's usually not the best way, because you'll be downloading 16 gigabytes to your machine and the connection may break and you're gonna have to start again. So this is not ideal. There are other applications, other ways to do that. We'll talk a little bit about symbols in a moment, but when you publish an application, you also publish the symbols. I'm just getting ahead a little bit so you know it's also there. And Azure App Service has a troubleshooting tab that you can use to also solve it. So if you click on diagnose and solve problems, you're going to have the diagnostic tools on the bottom right corner over there. And then you can collect a memory dump exactly on that point in time. And you can also monitor for crashes and transfer it to some storage account. Or you can proactively monitor the CPU and take the memory dump when some condition is reached. So it's super simple to use Azure App Service to take memory dumps. There's also an extension called Crash Diagnoser. There used to be a site called siteextensions.net. This has been replaced with NewNetDump.org, and you can also use that to install that on Azure App Service. So you have several different ways to take these memory dumps. Now that you know what it is, let's talk about WindyBG. WindyBG is one of the main tools, I would say the main tool used to analyze memory dumps on Windows. This is a node application and very advanced, very complex, not intuitive at all, but very powerful. So it's a very powerful tool that you're gonna have to learn how to use if you wanna actually do this. Also, documentation on working with memory dumps is not that extensive, so you're gonna have to work your way to understand how to use WindyBG, and it's a really difficult tool to master, but it's also very powerful. They're starting to update it, and now they have what's called the WindyBG preview. It's on the Windows Store, so it's super easy to install and update. And it's much modern and easier to use than the old WindyBG that we had before. You might even have WindyBG on your machine right now, but I recommend you install the WindyBG preview because it's easier to use and it has support for a much more things, much more functionality. We'll do a demo in the end of the session. You'll see how interesting this application is. You can also use NewNetDump. NewNetDump is a new tool here, and it's able to work only with .NET Core and .NET, now the new .NET 5, and also allows you to create and analyze dumps. Dumps can be created on one platform and analyzed in another using NetDump, what is not so simple to do using WindyBG. And dumps can be created with NetDump and analyze WindyBG. It's important that you understand that the commands in one tool are different from the commands in another tool. They try to make it similar, but sometimes they are a little bit different. Okay, so if you know WindyBG, you might have to learn to work with NetDump and learn a few more newer aspects. But NetDump is a tool. It's a command line tool. It doesn't have all the windows and switches that WindyBG has, but it's made to work with .NET, while WindyBG was made to work with C++ and native applications, and .NET came later and was adapted later to work with WindyBG. There's also .NET GC dump, which is a different thing. It actually generates a dump. It's a report that's you can use to open on Perfect View or Visual Studio. It's not a dump that you can open on NetDump or WindyBG. It's different. It's easier to use than the usual dump analysis. So even Perfect View and Visual Studio are easier tools. They are much more intuitive. And these are not compatible with other tools you might want to use. Usually, traditionally, we have been using to analyze memory dumps. It's only available for .NET Core 3.1 and later, so .NET 5 is also there. Let's talk a little bit about symbols. Symbols are super important. I showed you that when you publish an application, you usually you usually publish symbols, and you have seen those. Maybe you didn't know what it was for, but those are those .pdb files that get published when you publish a .NET application. So they actually connect your memory dumps to your code. So they are mapping what's in memory to your source code. You can have application symbols and infrastructure symbols, which is I'm calling here, which are usually the Windows symbols and for Windows APIs and .NET, the .NET libraries. They are what I'm calling infrastructure symbols. And you also have your application symbols. Microsoft publishes their symbols on a symbol store that you can, on a symbol server that you can download freely. I don't know if all, I cannot say that all applications have their symbols, but a lot of applications from Microsoft have their symbols published. So you can, all these libraries, you can download them from Microsoft's symbol server. And then, but they are really large. PDBs tend to be large, and also we have a lot of libraries, so they take a while to load. So a debug session, it can take a little while to be able to actually start. So usually what we do is we cache it on our local machines, and so the next session starts a little bit faster. The demos I'll be doing here with you, you're gonna see that they start really fast because the symbols are already cached. And also it's important to understand that every time a library changes, a new symbol has to be published. So when Windows API changes or .NET API changes, they have to publish new symbols. So if you're debugging an application with minor, a difference even in minor versions, you might have to download new symbols, and it might take a while to download again. Also, this cache is usually large, so be careful because it takes a lot of space. WindyBG already downloads the symbol by itself, you don't have to do anything. But when you're using NetDump, you usually use the .NET symbol tool to download the symbols before starting the analysis session. Microsoft publishes their symbol on this address, msdl.microsoft.com, where you can download from it. And for public symbols, you can use symbolsource.org and NuGet.org. And for private symbols, you can use Azure DevOps, MyGet, a shared network folder, and many other options. You might just publish them to app servers, for example, and then just download it from there if you want. That's totally possible. Private, it's very important that you store your symbols, or you won't be actually very effective when you're analyzing dumps. So if you forget to do it, you might have a little trouble. So use continuous integration in a symbol server for your symbols. That's the best thing you can do. By default, Visual Studio will publish symbols, and all Azure DevOps will offer a way to store the symbols. So it's all there already for you. You just have to tweak a little bit, and it's going to be there. It's possible to download symbols from Azure App Service. I already said that. And let's go to the demos. I left a little bit of time for the demos because these demos take a little while, and I want to get a little bit deep into them with you. So the first one we're going to do is with WindyBG. It's a memory leak with an ASP.NET Core application, and that's a 2.2 application if I remember correctly. Let's start. We'll start opening WindyBG here. So it's already here. I already opened it. And I'll open it again so you can see. But basically what you do is you have to know the address of the memory dump. I'll show you. It's this file here, which I'm going to use. So it is 519 megabytes. That's the size of the memory that was being used. And remember, this is a memory leak. This application was leaking memory. So what you do is you come over here, and first of all, you have to stop the previous debugging, which I was just trying here. So you open a memory dump, and you just paste it, the link there, and it's going to open for you. So it's just open. You can see a lot of information here about the dump already. So the system uptime, the process uptime, and other information. So we're going to start analyzing this dump. So the information that came to us is This application is leaking memory. As the time passes, it is using more and more memory, and we don't know why. So this is usually very common. In a large application, you can't find it because you run the application on your machine and you cannot find the correct place where the memory leak is. But users are usually using all the application and they find it, but we don't find it. So we take the memory dump and we analyze it. As this is a .NET, I don't remember, I think this is 2.2 or 2.1, you have to load SOS, which is a tool that will teach WindyBG a way to talk to .NET. So I'm loading it on the bottom line here. If you look at newer versions of .NET, you don't need to do that. It already does it by itself. I usually would do a command called verify heap. This is usually very important to verify that the memory dump is sound, but sometimes it's not, and you have to take another one. If the memory dump happens to be taken when there's a garbage collection happening, memory might be in the process of being moved, and memory dump might not work. Okay, I'm not gonna do it because it takes a while. I already done this before, and I know it works. So we're gonna go ahead and skip it. But what I can tell you is sometimes verify heap fails, and the memory dump is still usable. Okay, so you might try it before you, even if it fails. So here we get the execution engine version. All the comments are a little bit weird like that. They're not very intuitive, as I said before. So this is using a server mode for GC heaps, and this is the SOS version we're using. And we can take a look at the heap. So we can do, to try to understand a little bit more about this memory, what was going on with it. So we use the command eehip-gc, and we will show us all the memory. So we can see here that we have 4 heaps, as we had seen before here. So this is the first heap number 0, and we have the 3 generations here, where in memory each of them start. And we can see their sizes as well. So we can see that on heap 0, we can see that it is 80 megabytes in size. And heap 1 is, oh, that's not true, it's actually over here. And then we can see the second heap is at 76 megabytes. And then the third one is at 80 as well. And the last one is at 76 as well. And the total is 314. Megabytes for the GC. This is the managed heap. Okay. There's not analyzing memory dumps is kind of a process where you go. There's not a silver bullet in a way to analyze memory dumps. Okay. You go and you try to investigate. So it's very common that when you have a memory leak, you run this command, which is dump heap stat. This will show the statistics of the heap and what objects were there. So we can see we have a lot of memory. We have 96 megabytes going on arrays of bytes. Okay, and we have 144,000 array of bytes in memory. That's a lot. So what we are gonna do is I will not click on this, because if I click on it, this is gonna run forever. So I'm just gonna copy the command and paste it here. But this will show me all the objects. But I want only the larger ones, only the ones that have at least 5K. So when we do that, it's still a lot, but we can look at it. So let's take this first one, for example, and see what's in here. So this is the object itself, the array of bytes, and we can see here in the context is already a string. It looks like something from a header or .NET, HTTP, something about HTTP. Let's get an older one here, see if it's different. It's the same thing, very similar, actually very, very similar. On home context, that's a coincidence. Let's get an older one. Okay, same thing again. Okay, there's a pattern here. This is interesting. Let's get this one that we just looked at, and let's find its GC root. Okay, so you just arrow up and we do GC root, and it will show us the GC root for this object here. And the first thing I'll do is I'll search for my application here. What's in this? This is what's holding the array of bytes, okay? So on the top here, you're gonna see that there's some system threading thing holding it, but in the bottom, it's the array of bytes, and I will try to search for something of mine here. And I can see it's right here. That's an SMTP thing, that's from my application, memory leak app, and it's holding a list of something. That's interesting. It seems that this is our object. So what we do now is we are going to take a look at this object. Let's see what's in memory for this object here. So we're going to call dump heap and try to show for this type what we have in memory. So it's going to show all the SMTP objects we have in memory, and also the statistics, how many we have. So we might have tens of thousands, we might have one, we might have 10, I don't know. So it just found here 2 objects, and we only have 2 objects. And one is a logger, that's not ours, and the other is an SMTP, that's our object, okay? So we only have 1 object, and it seems that this 1 object is holding a lot of array of bytes. So we can take a look at it. We can come here to this object, and this will show us the object itself, and this is the object here, the address of the objects, and this is the object, right? We are here. So we have an accessor, a logger, which is the logger we saw before, an accessor, and some contexts. Let's see what this context is. This is the method table. This describes the object. This is the value, the actual object in memory. Okay, so let's look at it, and we can see that it's what it is. It's a list holding an HTTP context, and it has here 4,000 HTTP contexts in memory. So we already know that our object is holding HTTP contexts in memory, and it's not supposed to do that. HTTP contexts are supposed to be disposed at the end of the requests. So we know this is the root of the problem. And at this point in time, I would go and ask the developers to look at the code and try to find out what's going on there. Why is this object holding HTTP contexts, and probably the error is there. So this is this ends this first demo. We'll go to our next demo, which is actually using .NET the new .NET dump, which is also a little bit complex. So let me we'll do this on Linux. This is WSL, so this is super cool because we'll do the whole thing in Linux, okay? And we create the application from start, okay? So I'll just run these commands here to create the application. So it's creating a new MVC application, and then we're gonna run the application. I'm gonna open another tab here so we can do that while it's publishing the application. And then we're gonna run the application when it's done. And then in another window, we'll take the memory dump. Okay, so the application is running. And we'll run the process as it would be done on the server. So we run, let me increase this font size a little bit, .NET dump PS. It will show the .NET process we have here. So it's over here. This is the process we are going to use. I actually made it a little bit easier to actually do that. So we're going to collect this, oops, let me just copy the command here. Okay, this is going to get the PID of the process for us. So it's right here, okay? And then we're just going to collect this dump, and we're going to see it right into this local, and on the logs you're going to see that a dump was taken, okay? So this is cool to see that it actually writes dumps as well, and we can check it out now. Let's see how it is, how large it is. It's oops, 300 megabytes in memory. That's the memory that was in use, and we're going to analyze this memory dump. There's nothing much to see here, but it's interesting for you guys to understand that we can do it. Okay, so for example, we can come here and see the version as the same thing we did before. See this, the command is actually the same. So you can see that this is .NET 5 as expected. We can see the heap. The same thing, the same heap we saw before, but now this is in Linux. And we can also see the stack, what's on the stack. And I'm gonna add a -a here, so you can see details from the stack. So you can see exactly what's running right now, how many threads we have. I think we can run threads here and see the threads as well. See, these are all the managed threads. We're on thread 0 right now. This is where the asterisk is there. And this is showing us, it actually links to the source code because it found the symbols. So it's linking to the source code and to exactly what's running right now. Okay, and then I would start investigating the same thing I did on the other application. I would do here. There's a help command if you need, so you can try to understand what it's doing. Okay, so this is how you start using with NewNetDump. You don't even need to install WindyBG. Okay, and this with that I end our demo, and I'm gonna leave the reference here a little while. But we can take some questions if you want now. But these are the resources you need to start working with analyzing memory dumps. Okay, there's a lot of docs here on Microsoft Docs. Documentation on WindyBG is a little bit harder to read and more difficult, but it's also there. So here are the other tools as well. So. That was it, and if there are some questions, we can talk about them. Kendra.
Thank you so much, Giovanni. That was so cool. Yeah, there's so much that I still have to learn about analyzing memory dump collection. I always end up on documentation so quickly.
Yes.
We got some cool questions on Twitter, but we're going to go ahead and skip on to the next. If you are available to answer any of those, I'm sure they really appreciate it. But thank you so much.
All right. I can take questions on my Twitter if anybody has any questions. And thank you, Kendra. Thank you, everybody.